Hello, AI enthusiasts. Welcome to a new deep dive. Building on our previous talk about K means clustering and how it assigns points to nearest centroids using magnets, let us explore hierarchical clustering. Most videos on this topic show you abstract branching lines without explaining the soul of the data. In this video, we want to show something different, the story of a family tree where every data point finds its long-lost relatives through facial resemblance. In the beginning, we do not have any groups at all. Imagine a table spread with individual portrait photos. In hierarchical clustering, every single data point starts its journey as its own unique cluster. There are no predefined categories or magnets pulling them together yet. It is just 12 separate individuals waiting to find their closest match based on how they look. To bring them together, we need a measure of resemblance. Think of this like comparing eye color or the shape of a nose between two photos. In a three-dimensional space of features, two portraits that look almost identical will be very close together. We calculate the distance between every possible pair, searching for the two people who look the most like siblings. Once we find the two most similar portraits, we merge them. This is our first family unit. In the data world, these 2 points are no longer individuals. They now form a single cluster. This first merge is the smallest branch of our growing family tree. We repeat this logic, always looking for the next 2 most similar entities on the table. The process continues step by step. We find the next closest pair and link them. Sometimes, an individual portrait joins an existing pair to form a trio, much like a cousin joining a set of siblings. Other times, 2 separate pairs might find they look like each other and merge into a larger branch. We keep going until every single photo on the table is connected into one massive, singular family tree. This branching structure is what scientists call a dendrogram. It is a complete record of every relationship found in the data. The height of each horizontal bar tells a story. The lower the bar, the more similar the portraits were. A very high bar indicates that we had to merge 2 groups that did not look much alike. Unlike other methods, hierarchical clustering does not force you to pick a number of groups at the start. Instead, you decide where to cut the tree. Imagine drawing a horizontal line across your family tree. The number of clusters is simply the number of vertical branches your line passes through. This flexibility is the true power of the hierarchy. By moving our cut line, we can explore the data at different levels of detail. It is like choosing whether to study individual families or entire nations. You get to see how the small groups naturally roll up into the larger ones. Remember, the magnets from our K means discussion. There, we had to guess the number of magnets before we started. Hierarchical clustering is different because it builds the relationships first and lets us choose the grouping later. We are not forcing points toward a center, we are letting them find their own relatives. From individual portraits to a fully connected family tree, hierarchical clustering reveals the hidden lineage within your data. By merging the most similar points, one by one, we create a map that guides us from the smallest details to the biggest patterns. Next time you face a complex dataset, remember the family tree. Sometimes the best way to understand a group is to see how they grew together. Subscribe for more visual guides on how algorithms organize our complex world.